So we are given a piecewise function. We want to, for part A, find the average rate of change of f on that interval from -3 to 4. Average rate of change is just a slope. So all you need to do is find f of 4 minus f of -3 and divide it by 4 minus -3. F of 4 comes from the bottom function. So I guess off to the side here, we'll find f of 4. F of 4 is -4 plus 3 times the cosine of 2 pi. Cosine of 2 pi ought to be 1. So this is -4 plus 3, which is -1. And then f of -3 ought to be the square root of 9 minus 9. So that ought to just be 0. So -1 minus 0 over 7. Which that was supposed to look like a -1/7. That's better. And that's it for part A. That should have been easy. If they asked you, they might, if you're doing this on the digital test, obviously, you'll need to indicate that what is an average rate of change. An average rate of change is a slope between the 2 points. Not much other explanation needed. You may have to do something like this where you do a little bit of work and just come up with a simple answer. All right. Everyone good there?
Good.
All right, part B, we want to write an equation for the tangent line to f at x equals 3. So that means we need to find f of 3 and we need to find f prime of 3. So first off, f of 3 ought to be -3 plus 3 cosine 3 pi over 2. What's the cosine of 3 pi over 2? That's right. The cosine of 3 pi over 2 is 0. So -3 plus 3 times 0 is just -3. And then to find f prime of 3, we got to take the derivative of this. And the derivative of that is -1. And then the derivative of 3 cosine pi x over 2 ought to be minus 3 sine, 3 pi over 2 sine pi x over 2. And if we're going to evaluate that at -3, that's -1 minus 3 pi over 2 times the sine of 3 pi over 2. The sine of 3 pi over 2, you were wrong. I was also wrong. You didn't say anything today, Jenna. Okay. Oh well. Sorry, we got a little distracted because Noah finally decided to grace us with his presence here in person, much later than he should have been. So we have -3 pi over 2 times our sine of 3 pi. What was it? Yeah, sine of 3 pi over 2. What's the sine of 3 pi over 2? Should be -1. So we end up with a slope of positive 3 pi over 2 minus 1. And it will be y minus -3 equals that slope, 3 pi over 2 minus 1 times x minus 3. And that was your tangent line equation for part B. And that was worth 2 points. 1 for finding the derivative, 1 for writing the equation. Good or not?
Satisfactory.
Oh, wonderful. All right, part C. Asks us to find the average value from -3 to 4. So that's 1 over 4 minus -3 times the integral from -3 to 4 of, is it f of x? I think it's f of x, right? F of x. Now the issue with that is that f of x is a piecewise defined function. So we're going to have to split it 1/7 times the integral from -3 to 0 of, what was it, root 9 minus x squared dx, and then plus the integral from 0 to 4 of -x, I think it was plus cosine No, plus 3 cosine pi x over 2. Does that look right?
Yeah.
Oh, good. Okay. Cool. Now, to find the integral of the square root of 9 minus x squared, you've got two options. One is you could do a trig substitution. True? You'd let x equal 3 sine theta, dx would be 3 cosine theta, and you do all the conversion and all of that fun stuff. And it would be a little bit irritating, but you could do it. The other option is just use some basic geometry. This is the square root of 9 minus x squared. It's a semicircle with a radius of 3. So all I'm really looking for here is the area underneath this semicircle from -3 to 0, which is a quarter of the full circle. It's a quarter of a circle with a radius of 3. So you don't actually have to do any integration by hand to find that value. And you could just use the graph and the fact that that's a circle or semicircle and a quarter of a circle to use the geometry. Everybody good with that?
Cool.
Cool. Yeah. And then we have plus. Now we've got negative x squared over 2. Integral of 3 cosine pi x over 2 requires a u sub, or u equals pi over 2x. So we can probably do that in our heads though. So that's going to become plus 6 over pi, because we're going to have the 2 over pi out here and multiply it by the 3. And then sine pi x over 2. That piece has got to be evaluated from 0 to 4. And then we evaluate it all. So we got 1/7 of, looks like 9 pi over 4. And then plus, we plug in 4 to this. This is going to be -8. And then sine of 2 pi is going to be 0. And then this will be 0. And the sine of 0 is going to be 0. So most of that really annoying stuff disappears. We got 1/7 of 9 pi over 4 minus 8. Good or no?
Could you have done it another way, where you use, so there's a split into two functions. If you made a separate 1 over b minus a for the integral of the function from -3 to 0, and a separate 1 over b minus a for the integral of 0 to 4, and then you added those together, and then you just averaged those.
If you did each one separately, root of 9 pi over 4. Hold on 1 second. And then you'd have 1/4 of that. And then average those. Is that what you're saying?
Yeah, I guess that doesn't work.
You gotta do the full interval. If it asks for the average value of a function on an interval, you gotta do the whole 1 over b minus a of the full integral, and then any separation of the integral occurs inside of that 1/7 times it. Otherwise, it won't come out the same.
All right.
Oh, and this was worth 4 points. 1 point for splitting it into two integrals, 1 point for this value, 1 point for the correct antiderivative here, and then 1 point for the final answer. Everybody good with that? Okay. All right, part D, we want to know if there's a value of x at which f of x attains an absolute max on the closed interval. Well, if there is guaranteed to be a max by the extreme value theorem if f is continuous on the interval. What was it, -3 to 4, right? So if f is continuous on -3 to 4, it's guaranteed to have a maximum. Well, if we look at our functions, clearly from -3 to 0, this function is continuous and defined. And clearly from 0 to 4, this function is continuous and defined. Right? It's defined and continuous on both the intervals. So the only place where it might not be continuous is where these two pieces join up at x equals 0. So we'll use the definition of continuity to determine if the function is continuous at 0. And so that means that f of 0 needs to exist. It means that the limit as x approaches 0 of f of x needs to exist. And it means that f of 0 needs to equal the limit as x approaches 0 of f of x. So we need to show that all three of those things are true to prove that it's continuous at x equals 0. If we can prove that it's continuous at x equals 0, then we know that it must have a max on that interval. So first off, does f of 0 exist? Yes, f of 0 happens to equal, plug in 0, you get you plug in 0, you get 3. Good job. 9 minus 0 is 9. Its square root is 3. How about the limit as x approaches 0 of f of x? Since this is a piecewise defined function that has a split at 0, we need to look at the limit as x approaches 0 from the left of f of x and see if that's equal to the limit as x approaches 0 from the right of f of x. Well, from the left, we just found it, it's 3. On the right, we have x, which is 0, or negative x, I think, which is 0, plus 3 cosine of 0. Well, that'd be 3 equals 3. So the limit from the left was equal to the limit from the right. If those are the same, then that limit exists. And we found that that limit was 0. So the limit was equal to the value of the function. And therefore, yes, it is continuous. Yes, there is a max on that interval. Good or no?
Good.
That was worth 2 points. 1 for proving the continuity. 1 for saying yes, because of the extreme value theorem. All right. Anybody have any other questions on the first one there? All right. So for the second question, I'm not going to go through and read all that stuff. We'll worry about all the information that he gives us when we need it. First thing we need to do is find g of 0. And it disappeared. Where did it go? I must have deleted the page. There we go. All right. We need to find g of 0. So g of 0 ought to be the integral from -4 to 0 of f of t dt. And the integral from -4 to 0 ought to be this triangle plus this region of A. So the triangle is 1/2 the base times the height. And the region A they give us is 3. Now, if I'm right into one for B, which is 5. Since the region for A is below the x-axis, we'll subtract. So we got 9/2 minus 3, which is 3/2. Good or no?
Great.
Wonderful. All right. for g of 4, that's 3/2 plus the integral from 0 to 4 of f of t dt. I've already got the part from -4 to 0, so I'll just add in the part from 0 to 4. So that ought to be 3/2 plus 5 plus the integral from 1 to 4 of negative x squared plus 5x minus 4 dx. And then we'll just go through and evaluate all this. So, 3/2 plus 5 is 13/2 plus negative x cubed over 3 plus 5/2 x squared minus 4x from 1 to 4. We got 13/2 plus negative 64/3 minus 40, minus 40. No, that was a plus. I don't know why I got a minus in there. Plus 40 minus 16, and then minus the whole rest of this at 1, so negative 1/3 plus 5/2 minus 4. And I don't know, what does that come out to be? We got negative 64/3 plus 1/3, so that ought to be negative 63/3. So that ought to be minus 21. Plus 40 minus 16 ought to be a plus 24. We got a minus 5/2, and we got a plus 4. Looks like that comes out to be what? That's 13/2 minus 5 is 8/2. That's 4. Plus another 4 is 8. 32 minus 21 ought to be 11. Good or no?
Great.
And that was worth 4 total points. 1 for this. 1 for splitting this up into 2 integrals, 1 for the correct antiderivative, 1 for the final value. Good or no? Yeah, everyone's good? All right, part B, find the absolute minimum of G. Well, minimum of G means we need to take the derivative of G. Derivative of G is F. We want to know, when does this go from, we're looking for a min or a max? Looking for a min. So when does the derivative go from negative to positive? Well, let's see, here's our derivative. It's positive, it's positive. It goes from positive to negative. There's a local max. Then it goes from negative to positive at 0. And then it never does again. So 0. And then we also need to check our endpoints. So we are looking for G 0, G of negative 4, and G of 4. Well, G of 0 we already found. That was 3/2. G of 4 was 11. What's G of negative 4? Well, that's the integral from negative 4 to negative 4 of f. That's 0. So what's the absolute minimum? It's 0 at x equals negative 4. And they gave you 3 points for that, which seems pretty generous. 1 point for that, 1 point for checking these 2 values, and 1 point for the final answer with some justification. Good or no?
We are good.
Okay. Everybody besides Sean is doing okay? Cool. Good talk.
Yeah.
Aha, okay. All right, part C, find all intervals on which G is concave down. G is concave down whenever G double prime, which happens to be F prime, is negative. Now, F prime, this is just the slopes of f. So we look at our graph. And then the slopes of f negative. While the slopes of f are positive, from -4 to -2, then they're negative from -2 all the way to this minimum. This minimum occurs at -0.5. So from -2 to -0.5. I bet there's going to be some more. Positive slopes, positive slopes, positive slopes. At this maximum, we start having negative slopes all the way down to 1. So that's +0.5 to 1. And I bet there's going to be one more. Positive, 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 up negative slopes from, let's see, that one is 5/2 to 4. And that was worth 2 points, 1 for the intervals, 1 for the reasoning law. Any issues with part C or questions on part C?
Could you go back to the previous slide? I wanted to ask about the interval. Or I guess the question. I don't have it on my computer. So at -1, isn't that technically like a sharp corner?
Yes.
So if that's a sharp corner, does our interval end there and then, start? So like -2 to -1 and then -1 to -1/2?
Because the function, the derivative there is undefined. I see what you're saying, but no, any of those points where the second derivative is undefined, we will still include those as places where it's if both sides of it are still negative, we'll include those as concave down still. I think if you split it there at -1, they'd probably still give you the points. I'm looking at the scoring guidelines. They did not split it there. My tendency would be to not split it there either. I have a feeling that if you did split it there, you'd probably be okay. But yeah, you don't need to split it there.
Okay.
Any other questions, anybody else? All right, we have a curve here, a nice little implicitly defined equation here that then they eventually talk to us about polar coordinates with it. And we want to show first off that dy dx is equal to this thing. So in order to show that, we're just going to differentiate implicitly. So 8x plus 6y dy dx plus 6 dy dx equals 0. We'll subtract the 8x to get -8x. We'll factor out the dy dx. And we'll divide -8x over 6y plus 6. That's -4x over 3 times y plus 1. If you divide both the top and the bottom by 2 and then factor out the 3. So part A should have been pretty easy. Now they gave you 2 points for that. 1 point for implicitly differentiating and 1 point for simplifying it down to the answer. Good or no?
Could have gone about it the other way, right? Converting dy dx to the graph equation.
Sorry, say that by doing what?
You could have gone about it the other way, converting the differential equation to the curves equation.
Could have done that. You could have separated the variables and integrated. That'd be fine too.
All right.
Yep. Then you just have to pick any point that's on here. So you probably pick 0, 1 or something. I guess that's yeah, that's indicating that it's at 1. So I'd pick 0, 1 or 0, -3. I think this is probably easier. This is what they generally show in the scoring guidelines, is just taking the derivative of both sides of it and getting to that derivative. Because if you try to do it, if you do it implicitly, not implicitly, if you separate the variables and integrate, then when you plug in your initial condition, you're ending up, you're going to end up not wanting to solve for y in the end. You just have to put it into that form, which is fine. Just not something we normally have done. So up to you. But I would recommend this method that we did. All right, find the second derivative. So we'll take the derivative of this using the quotient rule. So let's see here. That should be our denominator times the derivative of our numerator minus our numerator times the derivative of our denominator, which should just be 3 dy dx over 9 times y plus 1 squared, if we just square each piece of that. And then we'll replace, and then it says in terms of x and y, so we got to replace the dy dx itself with the dy dx that was given to us. So first off, I'm going to cancel out the 3 and this other 3 with the 9. So I'm going to have negative 4 times y plus 1 plus 4x times negative 4x over 3 times y plus 1 all over 3 times y plus 1 squared. And if I look at their scoring guidelines, they didn't, I don't think, I mean, this is actually more simplified than what they left as their answer in the scoring guidelines. So this is good. That was worth 2 points. 1 for correctly using the quotient rule and 1 for the answer. I think A and B there should have been pretty easy 4 points. For part C, what are they asking here? They give us the curve in polar coordinates. They want us to find dr d theta. So we're just, we'll deal with the second part of it in a second. To find dr d theta, we just take the derivative with respect to theta. So if r, what was it, 3 over, is it 2 plus sine theta? Dr d theta, that's just the reciprocal rule if you want. Or you can just use the quotient rule. But if you use the reciprocal rule, it's just negative 3, put the negative out in front, times the derivative of the denominator, which is cosine theta, over the denominator squared. So there's dr d theta. And then, let's see, what is it? As theta increases, what happened there again? As theta increases, on what intervals is the distance between the origin and the point r theta increasing? So effectively, we want dr d theta to be greater than 0. We want the rate of change between r and theta to be increasing. So not between r and theta, but between the origin and our point r comma theta to be increasing. So we want the derivative to be positive. So when is negative 3 cosine theta over 2 plus sine theta squared positive? Well, the denominator is always positive, right? So we're really just looking at negative 3 cosine theta over something positive. So we need to know, when is negative 3 cosine theta also positive? Well, first off, negative 3 cosine theta equals 0 when theta is pi over 2 and 3 pi over 2. I assume they gave us an interval of 0 to 2 pi. Yep. So those are our values. We'll just make a sign chart and figure out when is that positive. Well, we plug in pi to negative 3 cosine theta. cosine of pi is -1, and -3 times -1 makes that positive. Plug in something less, those are both going to come out to be negative values, because this is first quadrant where cosine is positive, so -3 times a positive, and fourth quadrant where cosine is positive, so -3 times a positive is also negative. So this is increasing on the interval from pi over 2 to 3 pi over 2. And since we're talking about when is it increasing, we should put it in brackets, not parentheses. I don't know why I put a negative pi over 2 there, because it's not negative pi over 2, it's just pi over 2. Good? And that was worth 2 points, one for the right DRD theta, and one for an answer with some justification as to why. Any questions on that?
Could you also just talk about how cosine behaves in the quadrants as instead of during the design chart?
Oh, just in general. You don't need me to. Yeah, you could do that. That'd be fine.
Okay.
Yeah, if you just say cosine is positive in quadrants 1 and 4, making 0 to pi over 2 and 3 pi over 2 to 2 pi negative, and it's negative in second and third quadrants, so it comes out to be positive from pi over 2 to 3 pi over 2. That's totally fine. All right, part D. What was part D asking us? So S is the region inside the curve, inside of 3 plus 2 sine, 3 over 2 plus sine theta. But outside the curve, R equals 2. So R equals 2 is just a circle with a radius of, wow, that's the worst circle I've ever drawn. That's still pretty bad, but the circle with a radius of 2, outside the curve, R equals 2. So we're outside of R equals 2, but we are inside of 3 plus 2 sine, 3 over 2 plus sine theta. So outside there, inside here, we're talking about this region right here. And we want to write, we don't need to evaluate an expression that gives us that area. So first off, we're going to need to find where do these two things intersect. So we will set 2 equal to, let's see if I can write this correctly, 3 over 2 plus sine theta, which is going to give us 2 plus sine theta equals 3 halves if I cross multiply, or sine of theta equals -1/2. And that should occur at increments of pi over 6 in the third and the fourth quadrants. So that ought to be 7 pi over 6 and 11 pi over 6. And so our integral should then be, since this is area and polar coordinates, 1/2 of the integral from 7 pi over 6 to 11 pi over 6 of our outer radius, which was the 3 over 2 plus sine theta, squared, minus our inner radius, which is our R equals 2, squared d theta. And they don't ask you to evaluate, so there is your answer. Any questions on that?
We're good.
All right. Everyone besides Sean is okay? I hope. All right. How did the series one go?
Not as smoothly as the other ones, but
Not as smooth.
but the other ones weren't new content, so to say.
Well, the polar area stuff was. That's fine. All right, so if p is 3 and x is 8, we got negative 1 to the n plus 1. We said x is 8, so that's going to be 5 to the n. We're going to have a 5 to the n, and then we're going to have n to the third. And so this ends up being the series from n equals 1 to infinity of negative 1 to the n plus 1 over n cubed. And so first off, we know that, what does this do? This converges, right? We know that converges by the alternating series test. What about the absolute value of it? That's just 1 over n cubed. Does that converge or does that diverge? That should converge by the p-series test. So the series converges, the absolute value of the series converges. So for A, we would say it converges absolutely, because the series itself converges by the alternating series test and the absolute value of the series converges by the p-series test. And if you just did the absolute value of it, that's fine too. You don't need to prove that this one converges, because if the absolute value of it converges as well. Everybody good with A? That was 2 points. 1 if you did this, and 1 if you said this. John, you good with that?
Yeah.
All right. Part B, if p equals 1 and x equals 8, so that's going to give us n equals 1 to infinity, negative 1 to the n plus 1. Like we just said, x is 8, so that's going to be 5 to the n, which will cancel with the 5 to the n in the denominator. And now we just have an n down here. And so this series, we cancel those out. This converges by the alternating series test. If we take the absolute value of it, we just have 1 over n, and that diverges. You can say it's the harmonic series. You can say it diverges by the p-series test, either way. So we've got that the series itself converges, but that its absolute value does not. So we would say that B converges conditionally. And they gave you, again, 2 points for that. This time the points were associated with looking at this one and then having that answer. Good or no?
Earlier you said it converges absolutely if the absolute value converges. Did you say that?
If the absolute value converges, yes, that is the definition of converging absolutely.
Okay, so you didn't need to check the first one.
Right. I said that. I said you don't have to do this. You only have to do this if the absolute value doesn't converge. So we happened to, as we were simplifying it down, we just noted that it did converge by the alternating series test. But then when we took the absolute value, it still converged. So this became, sort of redundant. But down here, the absolute value diverged, so you have to go back in. That's why the points in part A were associated with looking at the absolute value and having it converge absolutely. But the points in B were associated with looking at the actual series and having it converge conditionally. So,
Okay.
does that make sense? Yeah.
Yeah.
Cool. All right. Part C, when x equals negative 2, for what values of p does the series converge? So part C is n equals 1 to infinity, negative 1 to the n plus 1. If x is negative 2, that's negative 2 minus 3, so that's negative 5 to the n over 5 to the n, and then what is it? N to the power of p. And we can simplify this down a little bit. The -5 can become -1 to the n and 5 to the n. The 5 to the n's will cancel. So we have -1 to the n times -1 to the n plus 1, which ought to be -1 to the 2n plus 1 over n to the p. Everybody good with that simplification?
Yeah.
Okay. And so then what is -1 to the 2n plus 1? If I plug in values of n like n equals 1, that's going to be -1 to the third, right? And then for n equals 2, that's -1 to the fifth, and -1 to the seventh, and then -1 to the ninth. And so effectively, that just becomes -1 over n to the p. The 2n plus 1 isn't actually changing the sign of that numerator ever. So now we've got -1 over n to the p. Well, this is just the p series test. So for what values of p should this converge? The p series test, this converges for p greater than 1, right? If p is less than 1, it diverges. If p equals 1, it diverges. The harmonic series, well, the opposite of the harmonic series. And if p is greater than 1, that's when 1 over n to the p converges. And that was worth 2 points. So 1 point if you got down to this simplification, and 1 point for the statement about p-series test proving that it converges for only p greater than 1. Everyone good there?
Good.
Great. All right, and then the last one. When p equals 1 and x equals 3.1, the series converges to a value of s. Use the first two terms of the series to approximate s. Use an alternating series bound, blah, 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 blah. Okay, so first off, let's write out the series of p equal 1 and x equal to 3.1. So that becomes n equals 1 to infinity of -1 to the n plus 1. We had x was equal to 3.1, so that's going to be 1/10 to the n. And then in the denominator, let's see, we had p was 1, so that's just going to be 5 to the n times n. And we could rewrite this n equals 1 to infinity, -1 to the n plus 1. 1/10 to the n means that we got a 5 to the n, and we've got a 10 to the n down here, and an n down here. And so we know that this series, it says, converges to some value of s. Use the first two terms of the series to approximate s. So let's write out the first two terms. Starting at n equals 1, this should be -1 squared, so that should be a +1, over 5 to the first, 10 to the first, that's 50 times 1. So 1/50th is our first term. Second term should be -1 to the third power, so that's going to be -1. And then we're going to have 25 times 2 is 50 times 100, which ought to be 1 over 5,000. And if we were to simplify this down, we got to multiply this thing by 100. So this is going to become 100 5,000ths minus 1 5,000ths, which will be 99 5,000. There's your approximation for the value of s. And then they wanted us to use the alternating series error bound. We can clearly see that this is an alternating series. It's definitely decreasing in value, and it's definitely the limit as n approaches infinity. This is 0, so we can use the alternating series error bound. The alternating series error bound says just look at the next term. So here's n equals 1, here's n equals 2. We need we'll say that the error is always less than the third degree polynomial. No, the third term. We'll just say we'll we'll say the third term. The error is less than the third term. Our third term ought to be -1, well, actually, not even third term, -1 to the fourth power here, which is just going to be 1, and then 5 cubed times 10 cubed times 3, which ought to be 1 over 125 times 3 is 375 times 1,000. And since 1 over 375,000 is, I assume, less than whatever value they gave us, less than 1 over 300,000. Therefore, the error must be less than 1/300,000th because we know that the error is less than 1/375,000. And that was worth 3 points. So 1 for the value, 1 for using the third term, 1 for that analysis there at the end, or the error bound, or something to that effect. Good or no?
Good.
Anybody have any questions on any of those 4 problems?